All right, I'm going to go over chapters 4 and 5 now. All right, I'm not in any hurry to go over these. We have covered chapters 1, 2, and 3. There shouldn't be anything specific on your next test that's just plucked out of there. Do you understand what I'm saying? But it is expected that you know how to design a form. All right, how to design a console app. So chapter 4, which we'll go over first, is on numeric and string data. There'll be a couple things in there that are either new or that we've just looked at in these last couple programs. Then we'll go over chapter 5, which is control structures, and that's looping. So I'm gonna write a simple program for you where I'm going to show you different ways that you can loop. All right. You don't have to write it yourselves. I think if you see me do it, I think that will be sufficient, but you know, whatever. So I'm going to jump into chapter 4 here. As you can see, chapter 4 is, let's do it that. There we go. Chapter 4, come on, crud, is how to work with numeric and string data. All right, so let's look at what's in here. All right, they talk about the different built-in types. Well, we've dealt with, so far in here, we've looked at strings, ints, and doubles. There are more, as you probably guess. All right, these simple data types are oftentimes referred to as primitive data types, just so you know that. They go by both the names. You know how to declare and initialize a variable. You know how to declare and initialize a constant because you just did those. All right? You know how to code an assignment statement. So again, if you were to say int age equal 21, that's an assignment statement. You are assigning the number 21 to the variable age. All right. How to code, that's an assignment statement. Arithmetic expressions, it's math. Addition, subtraction, multiplication, division, plus we'll look at the modulo, which is that remainder operator. I think we've looked a little bit at that already. How to work with the order of precedence, but the bottom line is parentheses trumps everything. And if you remember that, you're fine, because if you're ever in doubt, use parens. How to use casting, I did do that for you, but I'm going to show you that again. How to use the math class, guess what? You already did that. Remember the math.pow? So you've already been using that, but we're going to look at it again. Then we'll look at different things you can do with strings, declaring and initializing, joining and appending, all right, and including special characters in strings. So you'll see those. Then we'll talk about how to convert between different data types. And the chapter ends with first talking about scope, enumerations, and nullable. This nullable and this null coalescing, they're fairly new features in .NET, and then they go through the invoice total app. Now, if you think, you know what, I mean, you're going way too fast in here, and I really don't want to say anything. First of all, if that's the case, say something. And second of all, I would strongly suggest that you go back and you take a look at the programs at the end of the chapter, because they give you all the code. Plus, in that thing that I gave you, remember when I put it on your flash drive and then I had it out there, you've got all the book apps. They're all in there. You've got access to every one of those. All right, so let's just take it from the top then. So they show you here on page 101, these are the built-in data types. All right, you'll notice that for byte, there's a byte and an S byte. That S stands for signed. So a byte by itself is unsigned, so it only holds positive values, 0 to 255. An S byte is signed. So it's negative 128 to positive 127. Since you include 0 on the positive side, it's always one less than on the negative side. All right. Then you've got a short and an unsigned short, an int and an unsigned int, a long and an unsigned long. I mean, I don't want to sit, I think you get where I'm going here. Notice between floats and doubles, float 7 decimal places, double 14 decimal places. All right. Decimal, as it says, a non-integer number with up to 28 significant decimal places. Char for a single character. and bool for true or false. So we've dealt with most of these already. All right. Unless you're doing something where, I mean, one thing we could have done is we could have, for height and weight, we could have made them, we made them ints. We could have made them unsigned ints. We could have done that. Sometimes people do that, sometimes they don't. All right. We still would have had to check for out of range though. Okay. So that's why I didn't do that. I mean, I don't use unsigned with these very often, just so you know. All right. Again, these are typically referred to as the primitive data types. So you want a little more, you can read what's in there. How to declare and initialize? Guess what? You know this already. You know that you can either do it over 2 lines or you can do it all on the same line. So what's the advantage of doing it over 2 lines? Well, what if I'm going to sit there and write a program and let's say I do have 2 classes and my other class only has 2 students, but let's suppose that this is a university atmosphere and I've got several classes and maybe I've got a big lecture hall with 500 students, a smaller class with 100, and then maybe a lab with just 10. All right, and let's say that in each one of those they get tests. So I might want to create a variable that's called num students, and it might be that with one case it's 500, with one case it's 100, with one case it's 10. So then I might want to do that over 2 lines like this, where I would just say int num students, then I would ask how many students are in there as an example, and then assign it. All right. If you do know the value ahead of time, you really should assign it. So you know what variables are. As it says, commonly you initialize 0 for numeric variables, false for booleans, and the empty string, which is just double quote, all right, for string variables. All right. They give you some naming conventions. You should start your variables with a lowercase, and then if you run words together, like tax rate should be little tax, capital R, little ate. That's called camel case notation. And in fact, not only should you really do your variables like that, but your functions you should do like that as well. All right. When we get to classes in Chapter 12, if we had a class named tax rate, it'll be capital TAX, capital T, little ax, capital R, little ate. That's called Pascal notation. All right. And there actually is a programming language. I taught that many eons ago called Pascal. All right. So the next figure shows you some of the arithmetic expressions. So what's new in here? Am I right in assuming every one of you knows what these first 4 is? Is that a fair assumption to make? One thing you may or may not know, and I think I even mentioned this before to you, but if I come through here and I write a program and I say int x equal 14, int y equal 3, double z equals x divided by y. I don't know, you may remember this, you may not. What value is going to be in z? Yeah, just 4, 4.0. Since you're doing an int divided by an int, it throws away any decimal before it assigns it. So if you want to get around that, well, you could make them doubles. Now on your test, it asked you to make those 3 variables that you did the average of doubles. Some of you made them ints. I did not take off. But kind of as a warning to you, I will next time, because you have specific requirements on that test. You are expected to follow those. So we could have either A, made these doubles, or we could come in and say z equals, and this is called an explicit cast, double x divided by y, or we could have said z equals x divided by double y, or we could have even said z equals double x, oops, not that one, double x divided by double y. You could have done it any of those ways. This is called an explicit cast because you are doing the casting. Remember, if something is done explicitly, it means you're doing it. if we do one of those convert.toInts or convert.toDoubles or whatever, that's implicit casting. We are calling the software something from the software. All right, from the software is what's called its API or its application program interface. Now, so what else is in here? Are you guys all okay with a modulus? Now, if I gave you something like this, here, let's look. Hopefully I'm not giving you what's on the next test. I don't remember if this is on there or not, but let's say that you were supposed to read in a value between 1 and 100, and it was the amount of change you had in your pocket. We're just assuming the most you have is $1 worth. With me? So you read in 99. And I want the biggest number of quarters, the biggest number of dimes, the biggest number of, etc. All right? So I could say, for example, quarters, Q, equals, so I'm going to say here, int, I'm just going to call it num, equal 99. So quarters equals num divided by 25. 99 divided by 25 is 4, correct? No, sorry, it's 3. It's got a remainder. So this is going to give me 3. Then I can come in here and say, okay, now I don't want to change my quarters. I don't really even want to change num, but I can do that. I can say now num is equal to the num modulo 25. So that says divide it by 25 and give me the remainder. So now num is equal to 24. Does that make sense to you? Now if I come in and say num equal, I'm sorry, it's not num, that would be dimes, equals the num divided by 10. 24 divided by 10 is going to give me 2. So that's the number of quarters, that's the number of dimes. And now num equals num modulo 10. 24 modulo 10 is going to give me 4. That's what I've got left. All right, the number of nickels, all right, so nickels would be the number divided by 5. Well, 4 divided by 5 doesn't go in, that's 0. So there's no nickels. And pennies, what's left is the number modulo 5, which is 4. So if I had 99 cents, it would be 3 quarters, 2 dimes, 0 nickels, and 4 pennies. Does that make sense? Normally, when you use the modulo operator like that, it's either for dollars and cents or it's for time. Hours, minutes, seconds, etc. So if I gave you a really huge number and I asked you to figure out how many days, how many etc., you could do it based on that. You do a lot of work with modulo there. All right, so what's next? Well, a plus sign. I don't know if you know this or not, but this language doesn't care. So when I wrote this here, let me get rid of all this stuff here. When I came in here and I said int num equals 99, okay, most programming languages are like this. You can put a plus sign there. It doesn't buy you a darn thing, but you can do it. It won't give you an error for doing it. All right, well, what's the opposite? Putting in a minus sign, right? Negative 99, which is also legal. All right. Now, if I do this, this is what I want to show you here. I'm going to say int x equal 10, and I'm going to say int y. I'm not, in fact, I'll give y a value of 0, so it's got something in it to start with. Usually when I write this stuff, you guys know this already, I put a line through here. That's what most people who program do, so you can tell that's not as on the letter O. All right, there shouldn't be any problem with that anyway, but you get what I'm saying. Now, if I come through here, I want to show you 2 different things. I want to say y equals plus plus x, and then a little later, I want to say y equals x plus plus. Okay? Okay, right here, when you put plus plus in front of a variable, that's called the pre-increment operator. Plus plus adds 1. You can only use plus plus or to add 1. You can only use minus minus to subtract 1. That's how it works. Normally, you wouldn't use it like this. You normally use it inside of a loop, and you're going to see that in the next chapter. All right. But what this does, this is called the pre-increment, because the plus is before it. So that's the pre-increment. When you put it after it, it's called the post-increment. So what's the difference? What this does is it adds 1 to x. So x is now equal to 11. Then it takes 11 and it assigns it to y. So they're both 11. Does that make sense to you? Doing it this way, first it takes y and it assigns it to x. So y is equal to 10. Then it adds 1 to x. So x is equal to 11. See the difference? And minus minus works the same way except for instead of incrementing by 1, it's the post-decrement and the pre-decrement and the post-decrement. So it removes 1. All right. Normally, when you see the plus plus, and you're going to see this in the next chapter, but to show you this, if I wanted to count to 10 and I wanted to put it into a loop, I put something like this in there. 4 int x equals 1, x less than or equal to 10 plus plus x. That's normally how you use the plus plus operator, because it'll automatically add 1 for you. You don't have to do it like that, but that's normally the way that this is used. So that was plus plus and minus minus. Now, if either A, I confused you, or B, you still don't get it, there's examples in here. Follow the examples and see if you get the results, and there's a little bit of a description. As it says, these right here, those 5, plus, minus, subtract, multiply, divide, and modulus, they're all called binary operators. They need something on each side. Something has to go on each side of the operator. The other 4 that are in here, plus, minus, plus, plus, and minus, minus, those are unary operators. They go either before or after one thing. All right. How to code assignment statements? Guess what? You know how to do that already. Now, you may or may not know this. This is a shortcut. So, if I'm writing code, forget about this for loop in here. So if I say int age, let's say it's almost my birthday, let's say, and I'm 17. Okay? Now my birthday has come. You already know, believe it or not, you know 3 ways to add 1 to this. You already know 3 ways. One way is to just say age equals age plus 1. That'll work. Or you can say plus plus age. Or you can say age plus plus. Or you can say age plus equals 1. Now please look on the screen. When you use plus equals, that you can put any number there. So if I wanted to add 30 to it, I could say age plus equal 30. Totally fine. There's plus equals, there's minus equals, there's times equals, there's divide equals, and there's modulo equals. All of them are set up as shortcuts. If you're like, well, that just confuses me, and I'm not trying to be funny or mean, don't use them. It's totally fine. All right? And you're going to find that these occur in virtually every language that we'll go over in this program here. So you'll see them again. And again, there are examples in here. There's a plus equal, minus equal, times equal. Okay? And I'm not trying to confuse you. I'm not trying to go over this too fast. So next is the order of precedence. Well, look on the screen. They didn't put 0 in here because 0 is parentheses. But you do plus plus minus, minus, those two are first. The 1 and 2, they're first because they're unary operators. They only operate on one thing. And then hopefully back in the days of about junior high, you learned you do multiplication and division before you do addition and subtraction, unless you use parentheses. All right? And again, unless parentheses are used, you go from left to right, but you do multiplication and division and modulus before you do addition and subtraction. You do increment and decrement, so plus, plus, and minus, minus before you do a positive or a negative. Casting, I've already shown you, but here's some examples. Notice I did the double. Look on the screen here. There they're doing an int. Now, if you do this, notice on this line of code right here, it plucks off or removes, even if it was 93.999, it removes the decimal portion. There's a math function that we'll look at in just a couple of minutes that's called round, that will round things. That's not what this does. So it says you can use an explicit cast. I told you, the cast, that means you've done it. Cast, when you cast something, remember the example I just showed you there with a double, and I said there were 3 ways you could do it? Must always appear on the right-hand side of an equal sign. You can never cast on the left-hand side of an equal sign. That would make absolutely no sense to the system to do something like that. It wouldn't make any sense. All right, next is the math class. Now, it says here, too, I want you to look at this. It says the 5 methods shown in this figure are static methods. And you might say, well, that's fine and dandy. What the heck does that even mean? It means you can just use them. You don't have to create a math class. It's just available to you. So math.round is used to round numbers. Math.pow is used, we did that already with height. That was height squared. If in our formula for BMI, instead of saying math.pow height comma 2, if we'd have said height comma 3, that would have what 3 is, whatever 3 is. 4, what is 3 cubed? 4 cubed. I don't remember. But you get what I'm saying, right? There's a square root. Min and max is kind of neat. All right. It'll figure the biggest value or the smallest value. That may not seem like much now, but it'll matter more later. All right. As it says, if you want to use any one of these static methods, you code the name of the class, which is math, and a period. Why am I telling you this? Well, if you look on the screen here, I'm going to go back. This is the one we've already done, but I just want to show you this. All right, so I'm going to get rid of this, but if I type in here, math dot, whoops, try it again, dot, notice what all this is all available to me. Min, or max, min, pi, square root, round, absolute value, a cosine, a sine, a tangent, etc. There's probably in here a good 20 different things. So those are things that you can use, and they're just, for lack of better words, they're kind of freebies. They're available because you can just use the math class. All right, I don't want that, so. All right. Strings. Strings can hold virtually anything you want them to hold. You've already seen this. Here's the empty string. Now, you may or may not have seen this. Do you see this third line here? It says string message 3 equals null. Null means unknown. So, right now, okay, I haven't put your grades in for the test yet. I do have all of them except for James's, and I'll get his in just a couple minutes. And Gabriel's taken the test. He was sick last week, but everybody else has taken the test. All right? But the point is, right now, technically, your grades are all null. They're not 0. Nobody got a 0. You wouldn't want a 0 with your GPA. Null just means it's not known. All right? So you'll notice in here, they've got two strings. This right here, we're using the plus sign. You can see this if you look on the example with the names. But it's called concatenation. You are concatenating or gluing them together. So in this example here, name is equal to the first name and a blank space and then the last name. So it concatenates all that stuff together. Notice that if you join a number and a string, what happens? Now, I wouldn't do it like this. There's nothing wrong with it. It works. But I would have still used the .toString method right there in that example. That leaves no doubt. So as it says, a string can consist of any characters, any letters, any numbers, any special characters. It must be within double quotes, and whatever you put between double quotes is known as a string literal. All right, the null keyword, as it says there, means that the value is unknown. That's not the same thing as an empty string. An empty string means it has no value. Null means it's an unknown value. I mean, it sounds like I'm splitting hairs, but there is a difference. All right. You can use plus equal with strings. That's the only one of those plus equal. You can't use minus equal with strings, or times equal, or divide equal, or modulo equal. It doesn't make sense. But you can use plus equal to concatenate strings together. All right. Including special characters in a string. If you look on the screen here, we've already looked, I believe, at the \n for a new line. Probably \n and \t are the ones you're going to use 99% of the time. But putting that / character first, and notice it's a slash. It's not a slash. It's not the one that's next to your shift key. It's the \. It's the one above your enter key. It goes from left to right. All right. That basically is called an escape sequence. So once you put in the \n, it means, no, I want to treat this like a new line, which is like hitting the enter key. \t, it's like hitting the tab key, etc. And again, they give you lots of examples here. Now they talk about verbatim literals. I didn't even know that those existed. So what is it? It says, to quote a verbatim string literal, you quote an @ sign, followed by an opening double quote, followed by the string, followed by a closing double quote. Within it, you can put anything that you want. So notice, if you didn't put the @ sign in here, you've got a bunch of sets of double quotes. Can you see that? The system would be confused. It would think that each one of those things in its own set of double quotes was its own string. So they call that the verbatim string literal. I didn't even know that existed until I read this book. All right. All right, converting data types. Some of this we've covered. You've already done a convert dot to byte. You've done a convert dot to int, 32. You've done a convert dot to double. You've done those already. The other ones work in the same way. I think we've even done a convert dot to char. But the rest of them work the same way. Notice again, it says the classes that reference these types, notice it's string with a lowercase s. And it says it refers to an uppercase string object. Before, when I told you this, normally if you use an uppercase s when you're supposed to use a lowercase s, normally it'll still work. But you're just advised not to do that. All right. As it says here, each built-in data type is supported by a structure class within the .NET framework. And they talk about structures. That's in a later chapter. In Chapter 8, we'll talk about structures. So don't let that throw you. All right. How to use methods to convert data types? Well, guess what? You've done toString. We did that almost since day one. There's a regular parse, which we haven't used, but we've used triparse. That was in that isNumeric thing. All right. Plus, we've used the convert dot to double, the convert dot to int, etc., the convert dot to bool. So you've done a lot of these already. Again, one of you is going to have to correct me, send me an email, talk to me before or after class if I'm wrong, but I think it makes much more sense to show it to you and then go over it like this. So that I'm able to say, where we did this on the program in class, where we did this type of an idea. I think that makes more sense. Here, as it's saying, it's automatically doing a toString. Well, I leave no doubt. I always put in toString if I want to make sure that it's toString. Again, you've done these converts already. This is one time, just so you know, the convert dot to int, the convert dot to double. It's not done like that in every language. Most every language allows you to do it, but the syntax for doing it differs between different languages. All right. How to use methods to convert numbers to formatted strings? Well, believe it or not, I've already shown you these, at least some of them. I did F for the BMI. I did F2, which means it's a floating point number, which means it's a number that can have decimal places. And the 2 is how many decimal places. So I did it to 100th. All right. C we've already looked at for currency. Notice you can use them in uppercase or lowercase. All right. Now, just so you know, if I say that something is equal to 18, okay, so if I say, for example, double raise equals 18, you with me? And then I print it out as a percent, it's not going to print out as 18, it's going to print out as 1800. So if I want to use 18 and then print it out as a percent, it should be 0.018 or 0.18. All right. The other ones, exponential, digits, general, I've never even used any of those. But they give you some good examples on how you could use them down below. All right. Notice there's a format method too. So what is this saying? String.format says grab this monthly amount. All right. And what I want is I want it to be in currency, or I want it to be in percentage, or etc. All right. So there's always more than one way of doing the same thing. That's the bottom line. All right. All right. 3 other skills. Working with scope. Now, this gives me a chance to go back to the program we just did. There is a lack of scope, more or less, in the program we just did. What do I mean? Well, at the top of this program, we declared these variables. I think you'd agree with that. All right. That means since we declared them outside of any function or method, they're available program-wide. Now, let's assume for a second that I didn't do that. Are you with me? So let's assume that I took height and weight and I defined them inside of here. Then I'd have to put them in those parentheses, and they get passed. You know, when you put them in parentheses and you pass them to another routine, that's called, basically, they're put in their arguments that get passed to another routine. And again, I've given this example before, maybe not to you guys, but the other ones have heard it. Maybe I've even said it to you, but it's like if somebody says, clean the room, and you're like, what room? So if you say clean the room, and in parentheses you put in bathroom, bathroom would be a parameter that you pass, or an argument that you pass to clean the room. All right, now if you look in here, if we go to our input height, these variables were declared inside of here. They're local variables. The other ones were global. Since they're local, if we want to use them in other routines, we have to pass them to the other routines. Don't pass global variables, but what's the bad thing about global variables? They can give you what are called side effects. Okay? Now, again, you guys probably have heard me use this example already, but when you guys want to get your email, you go out to your Inside Rankin account, correct? I do the same thing. When I go out to my Inside Rankin, there's certain things in there that I can change. If I moved, I could change my address. If I was a female and was married or got divorced and changed my name, or a male and I changed my name, I could do that. But what can't I change in there? Well, I'd like to be able to go and add another 0 before the decimal place where they have my salary. But they don't let me do that. In fact, if I could get in there and do that, they'd probably catch on pretty fast. All right? But the point is, some of my information that's in there is global to me. It's stuff I can change or they can change. Some of the other stuff is totally unknown to me, or it's local to me where I can't change it, but they can change it. So if I get a 2% raise and I'm making 50 grand a year, all right, then it would be 51 the next year. Make sense? All right. So they come in here and they talk about class scope. And what they're saying is, since these two things were defined outside, kind of like the way we did it, they have class scope, which means they can be used anywhere in the class. These four things have what are called method scope because they're defined in here. So a method and a function, for right now, they're the same thing. So don't worry about the difference. We'll talk about it in chapter 12. So those are only known in here unless if I call a routine and I pass them to that routine. All right, so that's what they're talking about in here. So if that confused you, read this. Now, variables that are defined like the ones we did, global variables, they live as long as the program lives. Did everybody hear that? Because it's pretty darn important. Global variables live as long as the program lives. So in this example, these two variables live as long as that program's running. Variables that are local, like these that are shown here, they only live as long as the method or the function that they're running in live. Then they die. All right. What can happen is if you make everything global like we did, you can get what are called side effects. Sometimes a side effect is what you want. Sometimes it's not. I'm asking you this question. I'll give you a hint. The answer is yes. All right. So could I have come in here? I'm in my input weight routine right here. If I came in and said height equals 127 as an example, would I get an error message in there? I would, because that's out of range. But if I said 12, even though I'm in the weight routine, I can change the height because height is global. That would be an unwanted side effect. All right. So normally, as a programmer, you should shoot to have none of your variables global. Constants being global is considered totally fine because they don't change. But variables, you should shoot to have as few and ideally none, global. I put them in as global because that would be just one more thing I'd have to show you in the program. But as we go on, we want to totally minimize the number of local variables that we have. I should say we want to minimize the number of global variables we have, ideally none. Next are enumerations. I'll give you a 4-word definition of an enumeration. User-defined data type. That's what it is. So if you look at the example that they give here, they're creating a brand new data type right here that's called terms. See that? And they're putting it in here net 30 days, net 60 days, net 90 days. Well, probably you'd be more often than not would use it like this example. So now, net 30 days, whenever you use that, it's the number 30. All right. Net 60 days, whenever you use it, is the number 60, and 90 days would be 90. Now, who cares? Well, the way that you quite often use this, and they don't show it in here, is you would say something like this. I'm going to grab their example so I don't screw it up. Let's see if I can copy it in. I'm not even going to put it in a program. I just want to show you this. Okay, that's good enough. All right. one of these that you'll see quite often will look like this. In fact, many people will tell you that when you create these enumerations, since technically they're a constant, they will put them in all uppercase. All right, so I'm going to change this to days of the week. And I'll put all 7 in there just quickly. These can be in uppercase. They don't, or all, all in uppercase or whatever. I'm not going to even do that. We could do that though. All right. So now if I create a variable that's of type days of the week, all it can hold are those 7 values. Does that make sense? Now, what you may or may not know is I'd want to change this because Sunday has a value of 0. So all I have to do, I don't have to change all of them, just the first one. Now Monday is 2, Tuesday is 3, etc. See that? All right, so you often see it done like that. So an enumeration is a user-defined data type. All right, plain and simple. And then how to work with these nullable types and the null coalescing operators, okay? This I want to take just a second on. We must be buttoned up around a half an hour or so. Oh, we're at 41 minutes already, okay. So it says, by default, value types can't store nulls. So for an int, let's look at this. Let's go back to our program. So I'm hoping I get an error here. If you look on the screen. So I can come in here and do this. All right, so I'm going to come in here and do this just so you see it, okay? So I'm going to come in here and say this, string name. Let's say I don't know the name. So I'm going to say equals null. Okay, no error, correct? Now I'm going to say int age equals null. Notice it doesn't like that. And it comes back and that's an error, and it says cannot convert null to int because it is a non-nullable value type. So strings can be set to null. Most of your other primitive data types cannot be. I don't know if a char can be or not. I don't remember. Char mi for middle initial equal null. Will that take it? Doesn't like that either. All right. But I don't want to do that. I want age to be able to be null. I want to do that. I want age to be able to be null. So I can do it like this. See this? So I should be able to come in here and do this. You already saw what didn't work when I came in here and did int age equal null. But if I come in here and preface this with a question mark, all right, now it worked. All that is saying is it is possible that this variable can hold a value of null. You don't have to put that in for a string because strings can hold null anyway. But what are called the non-nullable values, which are basically the other data types we've talked about, you need to put in the question mark. Does that make sense? So why is that even important? When does that matter? Well, I mean, again, imagine I'm doing a program for somebody if they have a bunch of stuff married. I just hired you, James. You're just hired you as a programmer. And during the interview, we never asked you if you were married or not. And nobody's, geez, I don't know. Was he wearing a ring? I don't know. And a lot of people don't even wear a ring. So what do we put down for that? Well, we put down null because we don't know. Oh, won't take that. Well, now I can put bool question mark is married, and I can set it to null. All right. It says when you work with nullable types, there's two things that you notice has value. Has value returns true if there is a value, but if it's still null, it returns false. Okay, and value returns the actual value of the type. Now notice it says there's also, so this is the nullable operator, there's also a null coalescing operator. That's 2 question marks. It says it returns the value of the left operand if it isn't null, or on the right if it is. What the heck does that mean? Look on the screen here. Here's the example. And guess what? In the next chapter or the one after that, we're going to look at one with a question mark and a colon, but it's not the same thing. This says if quantity has a value, so if this has a value, it could be 0, it could be negative, it could be positive. But if it has a value, then assign that to QTY. If it doesn't have a value, assign -1 to QTY. It's a shortcut. It's like you wrote an if statement to do that. All right? I'd say for right now, I wouldn't worry about either one of those. Okay? Now, I will look, and if for some reason they're used on your next test, I don't recall them being used on the next test, I'll let you know. So the chapter ends with 2 different versions of this invoice total application. Now look at this. You put in a total, all right, 225. Notice the other 3 things that are in here, all of them are read-only. So you get a 25% discount. If you take 225 and you multiply it by 25, you get 5625. If you take 225 and you subtract 5625 from it, you get 16875. Does that all make sense? So it gives you this, it tells you the controls, and it gives you the code. The only thing that we haven't done is we don't say this dot close because we've got a better way of exiting the program. Saying this dot close exits it no matter what. And you typically, I mean, if I accidentally press exit here and I use their code, the program ends whether I want it to or not. All right, even though there's absolutely nothing wrong with doing it that way. Then they enhance it. This is the last page or 2 of the chapter. All right. And you'll notice with the enhanced one, you can do a bunch of these. Remember the payroll program that we did the first week or 2? Well, maybe we'd want to, in here, every time we did a new employee, we'd want total number of employees here. Total, I don't know, total gross pay, and then maybe we did taxes and total net pay. Something like that. All right. So this is enhanced. You'll notice still, there's the only thing that they're adding in here is the subtotal. That's it. Everything else is, for lack of better words, is pre or post calculated for us based on either a value we already had, which is like the 25% for the discount percent, or by the value we inputted for the subtotal. Does that make sense to everyone? Again, it's a little more complex program. You'll notice it has 3 different values in here. They're all defined outside of any function or method, so these are all global. These are all local. So if we want to be able to use those in other routines, we have to pass them to the other routines. All right. So it says if you understand the code in the enhanced one, you've come a long way. If not, go back and look at it. All right. So it is 11:08. I'm going to give you a little mini break. All right, so I'm going to start at 11:15. I'm going to start on chapter 5, right at 11:15. So literally in 7 minutes. So if you want to take a quick break, please do.